welcome again, everyone, to G Squared Academy. You know, excellence is epitomized. Today, I want to go through some organic past papers. You know, organic is generally one of those topics that is always on the exam. So I want to go through some organic past papers today with you so that these things can help you in preparation for your exams. Thank you, everyone, for all the support. Thank you for the likes. Thank you for the shares. Thank you for the comments. Thank you for the subscription to the channel. I really appreciate it. And I hope that it will continue to grow and it will continue to help you guys. So without further ado, let us proceed because, you know, we have lots to get through. All right. So this paper is actually from 2014, January 2014. There you go. All right, so we're just going to work. The more questions you work, the better it is for you because you get a better understanding of what your examiner is looking for. So the three structures, three organic compounds are shown below. You have an alcohol, which is compound A, you have an alkene, and then you have an acid as compound C. So you're supposed to state the homologous series of the species. I actually just stated the homologous series of the species there. So compound B would be an alkane, right? And compound C would be an acid, okay? So now we proceed along with the paper. It says here that you should, compound A burns with a blue flame in oxygen. Write a balance equation for this reaction. So compound A is actually ethanol, and it says that it burns with a blue flame. Ethanol would be C2H5OH, and if it burns in oxygen, it's going to produce carbon dioxide and water. This is a combustion reaction. And since it is being burnt, the water is going to be in vapor format, and carbon dioxide as gas. Oxygen is a gas, and of course, ethanol would be a liquid. So we want to balance this equation. Let's put a 2 right here, and then 5 and 1 is 6, and put a 3 right here. That's now 3 and 4, 7. So we can put a 3 here, and that's 6 plus 1, 7, 4 plus 3, 7. There you go. So that's our balance equation with our state symbols and everything. Okay, so we proceed. It says here now that we need to state which of the compounds A or B is more soluble in water. Give a reason for your answer. So let's look back at the compounds. A is alcohol and B is an alkane. So you're supposed to state which one is more soluble in water. Now, water is polar, so therefore it will dissolve polar substances. If you look at alkanes, alkanes are really non-polar. They don't have any charge distribution. That's what we mean by polar. Charge distribution, where you have a positive end and a negative end. With the alcohol, though, this OH group over here is polar. All right? The oxygen can be deemed to be slightly negative and the hydrogen slightly positive. So it is polar. And as a result of that, it will dissolve in water. And so therefore, the alcohol A would be more soluble in water. The reason for that is it has the OH group, which makes it polar. Okay? And so that would be the answer for that. So 1 mark for saying which one and 1 mark for the reason. The OH group on the alcohol makes it more soluble in water. Okay? So the next question says, state whether compound A or C would react more vigorously with sodium metal and give a reason for your choice. Right, so compound A was the alcohol and compound C was the acid. So you're now trying to think, okay, you know, sodium metal actually reacts with alcohols to produce the alkoxide, and it reacts with the acid to produce the salt and the hydrogen gas. So which one would it be more reactive with? Now, because acids generally react with metals, we can choose the metal, the acid here to say, okay, compound C being the acid would react more vigorously with the metal sodium. And the reason for that is So the reason for that is the hydrogen of the acid, the proton of the acid, is more of a proton than the hydrogen of the alcohol. So basically what we're trying to say here is that you have your alcohol, COH, right? And you have your acid, RC double bond O, OH. So the sodium would replace this hydrogen or this hydrogen. And we're saying basically that the sodium is more likely to replace the hydrogen of the acid because that hydrogen is more positive than the hydrogen of the alcohol. So you can just simply say that it is more of a proton than that of the alcohol. All right. So we press on now to our next question. It says, write a balanced chemical equation for the reaction of compound C with a metal. So this is pretty straightforward, really. So you have your acid, and I'm just going to shorten the acid as R, C double bond O, OH. Okay, and then I'm going to react that now with the sodium metal, which is a solid, of course. And this is going to produce R, C double bond O, O, Na, plus hydrogen gas. Okay, plus hydrogen gas. So for that, you're going to need 2 of that, and you're going to need 2 of this and 2 sodiums. Okay, and that would be your balance equation. The R, of course, represents the rest of the acid molecule apart from the functional group. So if you go back, you can see the number of carbons that the rest of the molecule has instead of the functional group and the R. And of course, your examiner would accept this just to show the R group there. Okay, so now let's press on to the next question here. All right, let's see what's happening. It says, describe one test that could be used to identify the gas that is produced in the reaction with compound C, between compound C and sodium. Of course, hydrogen is produced. So how do you test for hydrogen? You take your splint, of course, you take your splint, and you place it at the mouth of the tube, and you're listening for a popping sound, right? And if you hear that pop, you know that hydrogen is indeed being produced. All right, so that's that. So we're going to still continue. Let us proceed even further. Okay. Okay, so now we go on to question part G. It says compounds A and C react together in the presence of a catalyst to form a compound D. State the name of the catalyst and draw the compound that you would get from that. So first of all, our catalyst is going to be H2SO4, right? Concentrated H2SO4 will be our catalyst. Now, the 2 compounds were ethanol, let me just draw that out. So you have your 2 compounds, ethanol, those are hydrogens, of course, and then the other one was propanoic acid. Okay. So propanoic acid. And of course, you know that when an acid and an alcohol combine, you get an ester, and they're asking you now to draw that ester. Of course, in your ester, the acid portion is drawn first. So you're going to draw your acid portion first, C double bond O, O, and then you're going to connect that to the alcohol portion, which is ethanol. So you end up with something which looks like this. Yes, and then you finish your acid portion over here. It was propanoic acid, so it should contain 3 carbons. There you go. All right. So let me just erase this so you can clearly see what's happening here. Okay, so that's your acid. Yes. There you go. So this would be your ester, which would be ethyl propanoate. Maybe they'll ask us to name it later on. So we'll proceed. No, they do not ask us to name it. All right, so here we go now, another question. 2-methyl-butane and pentane are structural isomers with molecular formula C5H12. Define the term structural isomerism, and of course, structural isomerism really simply means that they have the same molecular formula and different chemical formula. So same molecular formula, right? That's the same thing, which is C5H12, but their structural formula is different. Okay, now what they're asking us to do down here now is that they want us, let me clear drawings there, they want us to draw the fully displayed structure of 2-methyl butane. So let us dissect this theme so we can draw 2-methyl butane. First of all, it's an alkane because it ends with ane. The longest carbon chain has in 4 carbon atoms, hence the name bute. So we're going to draw 4 carbon atoms in the longest carbon chain. 1, 2, 3, 4. There you go. Now it says that on the second carbon, and we're just going to number from left to right for simplicity. On the second carbon, we have a methyl group. So let me just number my carbon chain. 1, 2, 3, 4. And based on this name, it's saying that on the second carbon, there's a methyl group. So I'm going to add my methyl group right there. Okay. And then now, well, let me clear that just in case, erase this and add the hydrogens like this. Okay, then now we're gonna add, there's nothing else there, 2-methyl butane, so we're just gonna add hydrogens now. So we add all our hydrogens to the structure. Okay, there you go. And this would be 2-methyl butane. Wonderful. So now we proceed. All right, let's clear our drawings there so we can see what we're going on with. Draw and name one other structural isomer of C5H12. So we just drew 2-methyl butane. Maybe we could draw another isomer. So we could possibly draw all right, so now it says draw and name one other structural isomer of C5H12. So the easiest thing here to actually draw is pentane, which would be 5 carbon atoms in a chain, like that, 1, 2, 3, 4, 5. And then you add all your hydrogens, like so. That's pentane. We could also draw 2,2 dimethyl propane. 2,2-dimethyl propane would be another isomer. But this one is the simplest one that you could draw for you to collect all the marks for that question. Okay, so we proceed again on to the next question. Okay, so our next question now, ethanol can undergo various reactions, as you can see there, depending on the reagents and conditions of the reaction. Products with different functional groups can be formed. What is the functional group of ethanol? Of course, the functional group would be the OH group right there. So that's OH, COH, fine. Next question now, it says that table 2 summarizes the conditions and products of 2 reactions of ethanol. So we're looking at 2 reactions of ethanol. You're going to complete table 2 by inserting the reaction conditions and drawing the fully displayed structure of the products which would be formed. Take note that the type of product to be formed is given in the table. So they gave us the type of product to be formed, and we're supposed to highlight the conditions and draw the product. So let's see what's happening here. Of course, an alkene is formed here, and we're starting with ethanol, of course. So if we get an alkene from ethanol, it would mean that this is a dehydration reaction. And the conditions for that would be conc acid, something like H2SO4, right, at high temperatures. So we're going to H2SO4, that's H2SO4. And at high temperatures, so about 170 degrees Celsius. The ethanol would dehydrate, so it's going to lose water, and we're going to form ethene. Okay, this is our product over here. That's our alkene, and of course, water is also formed because this is a dehydration reaction. Okay, so that's that bit. The next portion of this thing now, you're given ethanoic acid, right? And you're supposed to state the conditions for that reaction and the ester which is formed. So what are the conditions for an esterification reaction? Again, you need conc sulfuric acid. okay? You can increase the temperature, so you're going to put some heat to that. And then you're going to get your ester, which is going to be, since it's ethanol, ethyl ethanoate, so that's going to look like this: C double bond O, CH3, O, C2H5. And of course, you can draw out the C2H5 just to show the connectivity of the hydrogens and the carbons to the carbon, etc. You can draw out the CH3 as well. Okay. Let's see if they did say fully displayed structure. If they say fully displayed structure, yes, they did. You would have to draw that out. So what they would be expecting you to draw, and let me just draw that over here. Actually, let me just clear all drawing so you can see that. So I'm just using all the space to draw the ester. All right, so this is what it would look like. Ethyl ethanoate. Okay, there you go, and another carbon over here. And that's your ethyl ethanoate. Right, so that would be our ester, which would fit right into that table there. So again, we proceed and let's see what we can get for our next one now. All right, so we proceed again. Figure 3 refers to the following reaction scheme involving 4 compounds A, B, C, D. Carefully consider the reaction scheme in figure 3 and answer the questions that follow. So let's look at this reaction scheme. Now, whenever you're given a reaction scheme, what you want to do is really start from the middle reagent or the middle reactant, and then you see how that species changes into these different things that are around it. So in the middle of this reaction scheme, what we have is an alkene. We can clearly see that from the carbon-carbon double bond right there. Okay, so you have your carbon-carbon double bond right there, and so we can clearly see that. Now it says here that B, for reaction 1, this alkene can be converted into an alkane. And if you look at the difference between these two things, you notice that there are 2 hydrogens there, right? Which means that you have added hydrogen to the alkene. That's a hydrogenation reaction. So reaction 1 is a hydrogenation reaction. Okay. Then now let's look at reaction 2. What's the difference there? Bromine. There are 2 bromines over here, which means that you have added 2 bromines across this double bond. Therefore, this is a halogenation reaction. Let's look at reaction 3. Somehow compound A has reacted with something to produce carbon dioxide and water. Carbon dioxide and water is a telltale sign that this is a combustion reaction. So reaction 3 is a combustion. And finally, what has happened here is that the alkene has been polymerized. So this right here is a polymer. Once you see these square brackets with the N right there, which tells you that N can be a very big number, from 1 to infinity, really, generally speaking. So therefore, this is a polymer of compound A. So what are they asking us to do in this question? It says identify the types of reactions numbered 1, 2, 3, and 4 above. We just said that reaction 1 is hydrogenation, reaction 2 is halogenation, reaction 3 is combustion, and reaction 4 is polymerization. So there you go. You'd have collected your 4 marks there from this reaction scheme. So again, we will proceed. Okay, so we proceed with this question. For part B, it says now identify suitable reagents and reaction conditions which could be used for each of the following conversions. Compound A to compound B via reaction 1. Now, if you remember carefully, you can go back in the video and look at it again. Reaction 1 was hydrogenation. So what are the conditions for hydrogenation? These conditions can vary a bit. But you definitely need a catalyst, something like platinum or palladium, generally speaking. You could use 450 degrees Celsius, 0 to 5 atmospheres. Okay, so the conditions can vary, but you generally need platinum or palladium catalyst to do this hydrogenation reaction. What about now? So we proceed. Let me clear that. So what about now compound A to compound C via reaction 2? So if you remember, compound C was Yes, so you remember that compound C was the 1,2-dibromoethane. So what would be the conditions for that? Well, to be honest, you don't really need anything for that one to occur in terms of light or anything like that. So that reaction would just proceed without any conditions of that nature. Okay, because the alkene is reactive with halogens without the presence of light. All right, so you would write that on this line right there. Now it says, given that R is an ethyl group, which is therefore C2H5, your ethyl group is going to be C2H5, right? R is C2H5. Remember now, this is what the structure of the compound look like. H, 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 and you have the R right there. Now they're saying that this R is C2H5. State the molecular formula for compound A. So basically, we're going to replace R with this, and now we're going to state the molecular formula of compound A. So all you need to do is just count the number of carbons here. So that's 2, 3, 4. So you write C4, right? And then now count the number of hydrogens. There are 5 hydrogens here. Okay, 5, 6, 7, 8. So it's C4H8. There you go. And that would be the molecular formula of compound A. So we proceed again. Right, so now it says, hence write a balance equation for an equation for reaction 3. Reaction 3 was the combustion reaction. So now they want you to write an equation for that. So what we have is C4H8 plus O2 to produce carbon dioxide and water. Now the problem a lot of students have is that balancing this equation is an issue. Of course, this is a gas, this is a gas, this is a gas, and this is also a gas. Okay, so balancing the equation, all you need to do to balance this is just look at the number of carbons on the right. It's 4. If it's 4, you just put a 4. Let me change the color for that. You put a 4 right there. Okay, then you look at the number of hydrogens. It's 8. So now you need 8 on the right. So this is 2 already. So you're going to multiply that by 4 and you're going to get 8 as well. Now look at the number of oxygens on the right. Yeah, 4 times 2 here. So that's 8 plus 4. That would be 12. So you just need to put a 6 right there. And that is be your balanced equation. And so we can now proceed to the next question. Let's clear all drawings. It said, describe a chemical test that can be used to distinguish between compound A from compound B. Now, if you remember, compound A is the alkene and compound B is the alkane. So basically, this question is asking you to distinguish between an alkene and an alkane. Now, there are a number of ways you can do that. One, you can burn them and look at the color of the flame. Alkenes generally burn with a blue flame, and alkenes may have like a sooty flame, yellowish black sooty flame, right? And then you could also react both chemicals, compound A and compound B, with a halogen in the dark. Now, if a reaction occurs with the halogen in the dark, we know that that is the alkene, because alkanes only react with halogens in the presence of a light source or in the presence of an energy source. Okay, so that's 2 ways you could actually distinguish between the alkene and the alkane. A third way that you could do it is actually react both compounds with acidified potassium permanganate. Okay, you react them both with acidified potassium permanganate. A reaction will occur with the alkene, but none will occur with the alkane. Okay, so that is another way. That's 3 ways you could actually use to distinguish those 2 species. Okay, so now it says here you're supposed to list 3 characteristics of a homologous series. And there are quite a bit of them. Number 1, they have the same general formula. Number 2, they react in the same way. So they react with the same things. Number 3, there is a gradation of the physical properties as you move along the group. What does this mean? It means that as you move from carbon number 1 to carbon number 2 to 3 to 4 to 5, you tend to move from gases to liquids to solids, which also means that you are changing the state of the species well, you're changing the state of the species, and so you're also changing the melting and boiling points. As you move from carbon number 1 to carbon number 2 to 3 to 4 to 5 to 6, etc., the boiling point is going to increase, the melting point is going to increase because you're changing from gas to liquid to solid. Okay, they also differ, and I'll show you this one. Successive members differ by CH2, okay, or a mass of 14. 14 because carbon is 12 and there are 2 hydrogens, so that's plus 2, so that works out to be 14. So successive members differ by CH2 or by a mass of 14. So therefore, the difference between methane and ethane is CH2, and ethane and propane and butane, butane and pentane, and you get the gist. Okay, so the 3 properties there, and I gave you more than 3. So we can proceed again. Let us see what is the next question to answer down here. It says, draw fully displayed structural formula for compound A, which has a molecular formula C3H8. So now what they're asking you to do is this. You have a formula here, C3H8. You have to determine which homologous series this belongs to. Okay, so now, is it an alkane, alkene, alkyl, acid, ester? We know it's not an ester because it contains no oxygen. That also eliminates acids. That also eliminates alcohols. So now we're left with alkenes and alkenes. Alkynes, they tend to not really test on, so we'll just focus on the alkenes and the alkenes. So what's the general formula for alkenes? Alkenes would be CnH2n plus 2, which means that the number of hydrogens would be 2 times the number of carbons plus 2. All right, so let's see if that fits into this. We have 3 here, so 3 is n, so that would be C3H2 times 3 plus 2. That's 8. There you go. So this is actually an alkane. And that's not what they're asking you for, really. They're not asking you to tell them it's an alkane. They want you now to draw the structure. So let us draw C3H8, 3 carbons in a chain like that, and we attach our hydrogens all around it. Remember the rules. Each carbon must have 4 lines or 4 bonds around it. Not any more, not any less. And that would be the fully displayed structure of your C3H8. Okay, this is looking good so far. So we can continue to proceed. And of course, you can see right there that this was from 2020. So let us proceed. Okay, so it says now, state the homologous series to which compound A belongs. Just recall that compound A is the compound that we just looked at, which was propane, C3H8, just a reminder right there. So that's, of course, an alkane, right? And that's your 1 mark right there. Then now it says that you should, let me clear the joins. You should write the molecular formula for the compound, which has 5 carbon atoms of the homologous series stated. So you're going to write the molecular formula for a 5 carbon alkane. And we just looked at the general formula. So therefore, we can just simply put 5 as N. Remember, the general formula CnH2n plus 2. So we're going to replace N with 5. So we're going to end up with C5H, 2 times 5, 10 plus 2, 12, C5H12. There you go. Wonderful. Now, the next question says that we ought to draw the fully displayed structural formula for compound B, which has the molecular formula C3H6. So now you see there's a compound B, which has the molecular formula C3H6. All right, so we need to determine if this is an alkene or an alkene. Now recall that the general formula of alkenes is CnH2n plus 2. Does this fit into that category? No, it does not, because this is C3H6, where H is 2 times N. N is always going to be the number of carbons, and 2 times 3 is 6. So therefore, this is an alkene. And what would be the structural formula now of this alkene? Alkenes have a double bond somewhere in their structure. So we're going to draw 3 carbon atoms in a chain like that. First of all, insert a double bond and attach our hydrogens. Recall, every carbon must have 4 bonds around it, or 4 lines. Okay, see, must be 4. Okay, so that's 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And so therefore, this is our alkene propene. Propene, this is our alkene propene. All right, so again, we will proceed. Let me clear all drawings first, and then let us proceed. Okay, so now it says state the homologous series to which compound B belongs. We just sorted that out. It's an alkene, so we're not going to dwell on that. Then it says write the molecular formula for the compound which has 5 carbon atoms for the homologous series stated up here. It's an alkene, and so you'd need to remember the general formula of alkenes, and alkenes would be CnH2n. So therefore it would be C5H10. There you go, you see that. And so we're good to go again. Let us proceed. All right, so what you follow in homologous series, write the general formula. The general formula of acids, Cn-1, H2n-1, COOH. Okay, then now for alcohols, it's CnH2n plus 1 OH. All right, now the name of the first member of the carboxylic acid group is actually formic acid, right? Or methanoic acid, which is the new name, methanoic. Okay, and then now the first name of the alcohol would be methanol. All right, so that's the first member of the group. Each of them have a 1 carbon acid. Okay, 1 carbon species rather. All right, so we will proceed now. Okay, so there you go, and that's for 2020. So here's another question. Compound C is a sweet smelling compound. Once they tell you sweet smelling, ester, just think ester, which is often used in flavoring and perfumes. It says state the name of the compound and the homologous series to which it belongs. I already said it is an ester. Now let us see how we can get the name. Now the name of an ester comes from the name of the acid and the name of the alcohol which made it up. The acid portion is drawn first, but that name comes last. So the acid portion, I always say acid portion drawn first, name last. So what you want to do with your ester is you want to divide it into the acid and the alcohol portion. So this is the division right there. The part to the right is the alcohol. The part to the left is the ester, is the acid. Sorry. So the part to the right is the alcohol. The part to the left is the acid. So what you want to do is basically count the number of carbons in the alcohol portion. It's actually 1. So you're going to find the prefix for 1 alcohol or 1 carbon species, and that's actually meth. And to that, you're going to add il. So it's methyl. All right. Then you're going to count the number of carbons in the acid portion. And of course, you can clearly see that it is 3, 1, 2, 3, right? And then you find the prefix for 3, and that's prop. And you're going to put prop, right? And then to that, it may not hold here, so I'm just going to put a little dash. To that, you're going to add anoate. Okay, so this is going to be methyl propanoate. That's the name of this ester. And of course, it's an ester, so that's your 2 marks right there. All right, I just put the dash there because of the space. That's all. Okay, so let's clear our drawings and let us proceed. It says, draw the fully displayed structural formulae of the 2 molecules that are produced when compound C is hydrolyzed. So this is compound C, and what they're saying is that it is hydrolyzed. Let's look at the word hydrolyzed. Hydro means water, lyze means split. So it means that water has split compound C into whatever made it up in the first place. Okay, so it has split it into whatever has made it up in the first place. So we need to now look at compound C and see what made it up. All right, so remember, it is made up of an acid and an alcohol. And if we split it right there, that is where the water is going to split it. Then we get the acid and the alcohol portion. So what does an acid portion look like? I'm just going to change the color here so you can see that. So all you need to do after you've done that is just add a OH on that side. And what you get is 1, 2, 3 propanoic acid. On this side now, you're going to actually just add a H. There you go, H, and this now becomes methanol. Okay, so your fully displayed structures would actually be propanoic acid and methanol. So when they ask you for that down here, right, you just draw your propanoic acid, C11O, OH, 1, 2. All these are hydrogens, of course. Okay, and then you draw your methanol. Let me just change the color for that. And this is your methanol, HOCH. There you go. And that would give you your marks. So far, so good. So we proceed again. Okay, so here's your next question. It says, ethanol is widely used as a solvent for making cosmetics and perfume. So it's used for those things. This is ethanol, and this over here, as you can see, is an acid, compound D. State the name of compound D and identify the reagents and conditions necessary for ethanol to be converted into compound D. All right, so this is ethanol is being converted to acid. This is ethanoic acid. So that's an alcohol being converted into an acid. So what do we need for that? It's really an oxidation reaction, because as you can see there, the ethanoic acid has 2 oxygens and the ethanol only has 1. Further to that, you'll notice that the ethanol has, 3 and 2, 5 and 1, 6 hydrogens, but the ethanoic acid has only 4 hydrogens. So therefore, this has lost, the ethanol has lost hydrogen, which is oxidation, and it has gained oxygen, which is also oxidation. So what are the reagents and conditions necessary for that? It would be good if we have some acidified potassium permanganate. Okay, that can work for it. And if you apply a little heat to it, then you get your acid from that. And that's all we need for that right there. So we clear all drawings and we move on. Okay, so the next part says, now explain how ethanol can be made from the fermentation of sugar, include chemical equation for the overall reaction process. All right, so fermentation. So now the thing about it is that your examiner expects you to know a little bit about biology, and fermentation really is the anaerobic respiration of glucose, which means that respiration without oxygen. There are 2 types of respiration: aerobic, which is with oxygen, and anaerobic, which is without oxygen. So the anaerobic respiration of glucose is done, and that process is fermentation. Now, this is done using yeast. Now, there's an enzyme in yeast called zymase. So if I take my glucose, C6H12O6, right, and I treat it with zymase, right? And this is less than 37 degrees Celsius because of course, enzymes can be denatured, right? Or inactive. So therefore, it's going to be less than that. And what's going to be produced is ethanol, C2H5OH plus carbon dioxide, all right, which is a gas, of course. And we're just going to call ethanol a liquid right there, even though it's probably going to dissolve in the water. So you take your glucose, you subject it to zymase without oxygen, and you're going to get your ethanol and your carbon dioxide. And this is the equation for that. And of course, you can balance that as well to get your accurate equation. Right, so you can balance that equation as well. That put in a 2 there and you drop a 2 there and you are good to go. Okay, so basically it is the anaerobic fermentation of glucose which produces the ethanol, and we call that fermentation. All right, so we will proceed now. Again, let us clear all drawings and let us move ahead. So state one other use of ethanol. So apart from use of ethanol in fermentation of sugar here, or the production, right there, ethanol is used as a fuel, of course. It's used as a biofuel, all right? Of course, it's also used in alcoholic beverages, and it's using to make perfume and cosmetics and those things, etc., etc. It may also be dehydrated to form an alkene, which would then be used to make polymers. Okay, so that's a number of uses of ethanol. So let us proceed again. Let's clear all drawings. All right, so here we go again. Ethene undergoes a halogenation reaction to form 1,2-dichloroethane. Draw the fully displayed structure of ethene. That should be pretty straightforward. It's ethene. So let's just do that quickly. All right, so that is ethene, C double bond, C, H, 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 H. And that's our ethene right there. No time for hanky-panky. So let us clear our drawings and move on. It says, draw the fully displayed structure of 1,2-dichloroethane. So what you know about alkenes is that they undergo addition reactions. So basically, all that's going to happen is that the chlorine is going to be added across the double bond. Okay, so this is your ethene. I'm just going to redraw the ethene, C double bond, C, H, 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 and we're adding chlorine to that. So the double bond is going to break, right? We're going to split the double bond, and a chlorine is going to come there, and another one is going to go there. Okay, so what we're going to end up with is this C, single bond C, H, and I'm going to clear off this at the top up here now so we can get some space to work, some of it at least, and you're going to get a hydrogen. You're going to get a hydrogen there, and you can put a chlorine there, H, H, and that's your 1,2-dichloroethane. Wonderful. So again, we will proceed. It says, is the halogenation of ethene an addition or substitution reaction? I actually just said that. It's an addition reaction. Substitution means that you're replacing one thing for another. We did not replace anything there. We simply added the chlorine molecules to the ethene, right? And of course, you can see this is January 2018. Again, so we will proceed again, folks. All right, so this is the next part. Dichloromethane can be obtained from methane. So this is now an alkane. This reaction takes place in 2 steps. Write balanced equations to show how each step in the formation of dichloromethane. So first of all, you want to know what dichloromethane looks like, and then you can decide. So you have methane, so it's 1 carbon, you have hydrogen there, you have hydrogen, then you have 2 chlorine molecules attached to that. No, this form comes from methane, which is carbon bonded to 4 hydrogens like this, okay? And so therefore, let me just put a little line between that so we can see the difference there. Here you go, right? So now we want to see how this thing occurs. How does this change to this? Well, first of all, you're going to react in light. Let me just put light, chlorine, okay? Gonna add chlorine to that. The chlorine molecule, let me actually split up the chlorine molecule here. The chlorine molecule is going to basically replace one of the hydrogens, and that hydrogen is going to bond with one of the chlorines. So what you're going to end up with over here, and I'll change the color again so you can see what is happening. You're going to end up with C bonded to hydrogen, 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 and then the chlorine is going to replace one of the hydrogens plus hydrogen chloride, HCl. Hydrogen chloride. Now, this is the first step in the process. So we're now going to take this species, which is monochloromethane. We're going to take monochloromethane now, and we're going to react it with some more chlorine. So I'm going to clear all the drawings so you can see that. Okay, and let's use the red because the red is nice. So we have our monochloromethane here. Right? This is chlorine here, and this is hydrogen. That's hydrogen. We then react it with more chlorine in the presence of light, right? And then the chlorine is going to replace another hydrogen, and then the hydrogen is going to combine with the chlorine that was left back. So we're going to end up with CHHCl, Cl plus HCl. Okay, so this would now be the second step in that process. All right, so we will proceed again. Let us clear our drawings and see what's happening down here. Is the halogenation of methane an addition or substitution reaction? Based on what I just did, you can clearly see that it is a substitution reaction. Okay, so again, we will proceed. All right, so again, we proceed. It says here, ethene and propene are typical monomers, which are used as starting materials for the making of polymers. In forming polymers, ethene and propene undergo addition polymerization. Your task, define the term polymer. Now, I tend to do a very weird thing with this. And what I say is that mer means unit. I don't know if that is actually in anything, but I just say mer means unit. And mono is one for sure. Mono means one. Okay, poly means many. So monomer means one unit and polymer means many units. So a polymer really is a molecule which is formed from a simple repeating unit called a monomer. Right? So a polymer, that's what a polymer would therefore be. Define what is meant by addition polymerization. Addition polymerization simply means that the two species or the species, the monomer units are being joined continuously to make the polymer. Okay? That's all that's happening there. Now, state one, use each of the following polymers: polyvinyl chloride, which is PVC, PVC pipe, PVC pipe. Just try to remember that. PVC is used in pipes, okay? Because they corrode and they last long, etc., etc. Another one is Teflon. Teflon is used in non-stick pots and those sort of things. It's a very hard material, so it's used like that in non-stick pots to stop the pot from sticking, right? Polyphenol or polyethylene, right, is used to make polybags. There are these clear bags that sometimes you see sweets being wrapped in them, some little thin bags, that's polythene bags. So they're used to make plastic bags. Okay, so we will proceed again. Okay, so here's another question. Compound A, C4H10, compound B, C3H6 are both hydrocarbons. State whether compound A is an alkane or alkene. We did something like this before. It is an alkane because the number of hydrogens is 2 times the number of carbons plus 2, C4H10. All right, so it's an alkane. State one use of compound A. Butane can be used as a fuel. That's what they use in these compressed gas tanks that you use at home sometimes, butane or propane, right? LPG gas, liquid petroleum gas. All right, so then now compound A reacts with chlorine gas to produce a colorless compound and a gaseous byproduct. State one condition that is necessary for this reaction to take place. Now, compound A is an alkane. For it to react with chlorine, it must take place in light. Okay, so light is necessary for that to occur. And that is really what you need as your answer there. Then it says, draw the fully displayed structural formula of the product, the colorless compound formed when 1 mole of compound A reacts with 1 mole of chlorine gas. So basically, you have C4, and let us draw that now, C4H10, right? So it's 4 carbons in a chain, like that. Then you have your hydrogens, okay? Like this, right? Hydrogens are very annoying to draw, to be honest. That's why we always like to use the skeletal structure. Okay, so now 1 mole of chlorine has reacted with this molecule, which therefore means that only 1 hydrogen will be replaced. You have to be very careful. Notice it said that, 1 mole of compound A reacts with 1 mole of chlorine. When that occurs, you're going to get your hydrogen chloride and your haloalkane. So all we're going to do here is we're going to replace one of these hydrogens and we are going to use chlorine there. So we're going to put chlorine in its stead, right? Plus hydrogen chloride. So this is actually the structural formula that they want, this one. And of course, some of you may ask, sir, could it be on another hydrogen? It can be on any one of them, really, at this stage. Okay, but just make sure you remember it's 1 mole of compound. that was reacting. Okay, so we proceed again. Let us clear our drawings and see what we have down here. It says briefly describe one test that can be used to identify the gaseous byproduct. The gaseous byproduct, if you recall, was hydrogen chloride. Hydrogen chloride. This looks very familiar to us because it actually looks like hydrochloric acid. How would I identify an acid? Well, I would take the pH scale or take universal indicator, dip it in it, and then compare it to the pH scale. Also, you could use litmus, which it would therefore turn blue litmus paper red. Okay. And so therefore, that's how you could identify that this is hydrogen chloride, which is also an acid. You could dissolve it in water as well. Dissolve the gas in water and test the pH of the resulting solution. Okay, so let us proceed. So here, and this is probably going to be our last question. It says the molecules shown below can be used to produce polymers, which are very useful in industry. So if we look at this now, we notice there is an acid portion there, right? A partial structure of the polymer is shown below. So here's a partial structure of the polymer. Of course, they can't show you a lot. They just have to show you a few. So they give you 3 units joined together. You know it's 3 units because this is a part of 1 unit, and there are 3 of these in the structure. Name the functional group or the link present in the polymer. So you're looking for some special group, a functional group that's present here, and there it is right there. And what is this? This is an ester link. So our polymer here is an ester. All right. Now it says name the type of polymerization reaction that has taken place and state one possible use of these types of polymers. So the type of polymerization is actually condensation polymerization. Okay, and so that's condensation polymerization. And what are these things used for? Esters are usually used for perfumes. You could actually get perfumes or aromatics, those sort of things, smelly things which not smelly as in bad, but smelly as in sweet smelling things. Okay, so that's a use of the polymer. So we'll clear drawings there so we can get some space. Name the byproduct that is formed in this polymerization reaction. So the type of polymerization here is condensation polymerization. Condensation really means in this context that 2 species come together to form a new species with the formation of a small molecule, which is usually water. Not always water, but usually water. So when they talk about byproduct here, they're really talking about H2O. Okay, in this context. So that's the byproduct that's formed. So you have 2 things coming together to form this new product, this one new product, and water is produced as a result of that. All right, so I hope you guys have enjoyed this video, and most importantly, I hope it has helped you guys. Please continue to study, continue to prepare for your exams, and I wish you all the best. I will put out more videos revising the different topics of the exam before the exam comes around. So I hope you guys enjoy. Look out for my chemistry marathon, which is coming up. You know, you can sign up. We're going to do it online. So look out for that one. All right. Thank you guys for watching, and I hope you really learned something from this video. All the best. See you next time.